Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! You're listening to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do. But y'all, it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor our students to be mathematicians as we co-create meaning together. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
So in the last couple of episodes, we've been talking about decimal multiplication and helping make sense of multiplication of decimals in kids' heads. So today we're going to tackle some gnarly problems and share what happens in our heads as we solve them.
Because if we can build really reasoning with decimal multiplication, then we can get super flexible and have a lot of fun deciding kind of using that anticipatory thinking. What strategy do we want to use here? And then that's where math really becomes more and more figureoutable and fun and creative all at the same time. All right, Kim, I got a question for you.
Yep.
Here is what we would call a gnarly problem. And I'm going to give it to you and then I'm going to ask you what comes to mind, and just you try to be as explicit as you can about all of the things. Even if you decide to do something, but you had considered something else, I want to hear what you had considered and then what you were like discarded, and just really put your brain out there. Okay.
Okay. All right.
Here's the problem. 0.77 or 77 hundredths times 2.4 or 2 4/10.
Okay.
0.77 times 2.4.
So, what's interesting is that in the last episode, I kind of mentioned that a lot of times with decimals, I yank them out of, I yank the digits out of the decimal place value, and I solve it however I want to solve it. And then I consider the fact that I was really dealing with decimals. I'm kind of thinking about what I want to share here. So maybe I'll start sharing and you could say, no, I don't want to hear that strategy, but here's what I'm thinking. I actually like percentages as well. So I kind of want to mix that in a little bit, if that's okay.
Yeah.
So I want to think about 0.75 times 2.4. And so bear with me for a second, because I know that 0.75 is the same thing as 75%.
Yeah.
And I know that 2.4 can be considered as $2.40. So I want 75% of $2.40. Okay. And that is $1.80 or 1.8.
How do you know? How do you know it's $1.80?
Because 75%. So each 25% would represent 60 cents. So I need 3 of those 60 cents to be $1.80.
To get 3 of those quarters, 75%. That's $1.80. Okay, cool.
So far I have 0.75 times 2.4 equals 1.8. So I'm actually pretty close. So now I want to think about
while you're thinking, sorry, because the problem, and this is all audio, so I'm just going to say it again, because the problem was 0.77 times 2.4. Right now you have 0.75 times 2.4. Okay, sorry to interrupt.
So I am 2% or 0.02 away. So I'm actually going to go 2 times 2.4 is 4.8, because then I'm going to scale down. Does that make sense? So 2 times 2.4 is 4.8. So that means 0.2 times 2.4 is 0.48. And 0.02 times 2.4 is 0.048.
Yep.
And that's
Scale
helpful
down.
because I can use the 0.75 and the 0.02 each times 2.4 to get 0.77 times 2.4 is 1.848.
Because 1.8 plus that 0.048 is 1.848. Nice.
And the thing is, I don't question it. Like
you're not going off in your calculator right now, typing it in to make sure. Like you're really
no,
confident
because
in those
I used
values.
pieces that I knew. Yeah.
Yeah, pieces that and you walk through each. You're like, yep, this, yep, and this, yep. Nice.
Is that what you would have done?
No.
Oh, you want to share yours?
Yeah. So I'm gonna think a little bit about 2.4 times 0.77. I think that's where I'm gonna go.
Okay. All right.
I think that's where I'm gonna go. So I'm honestly in a ratio table, and I'm going to think about 1.77, and I'm going to then double that to get 2.77s. So I'm sort of thinking about 2.77 cents. So 2 times 77 cents would be $1.40, and 14 is $1.54. So was that kind of explicit how I just did that?
Yep.
I thought about 70 cents and then two
cents.
sevens. So 277 cents would be $1.54. And I still need, so the problem was 2.477 cents. Right now I've got 2.77 cents. So I need 0.4. So I'm going to go ahead and double that to get 4.77 cents. So double 1.4. Well, I know double $1.50 is 3. So that's going to be $3.08. $1.50, and then 4 cents and 4 cents. So 4 of these 77 cents is $3.08. Now you might be like, Pam, why do you need 4 of them? Well, I don't, but I need 0.4 of them because the problem was 2.477 cents. I've already got 2 of them. I had 4 of them. 4 was $3.08. So 0.4 is going to be a tenth of that. So a tenth of 4 is 0.4, and a tenth of 3.08 is 0.308. 0.308. So now I've got 2.77 cents, and I've got 0.477 cents. Those corresponded to 1.54 and 0.308. And so when I add 1.54 or $1.54 to 30 cents with this 0.8 of a cent left over, $1.54 and 30 cents is $1.84 with that 8 thousandths left over. So I've got 1.848. Oh yeah, which is what you had. Sorry, no one's surprised. I was actually, I'd forgotten you did it because I was doing it.
You're thinking
my own way. Yeah, I was actually thinking.
Yeah. Very
cool.
cool.
Those are relationships. But like both of us decided to use different relationships that could sort of be helpful. I'm a little curious to wonder, what if I would have given you the problem 0.77 times 0.24? I wonder, would you have done anything different? Would that have struck you any different?
That's a good question. I feel like I might have thought about whole number relationships and then scaled down. Maybe, I don't know. I still like the 75 cents. I feel like I still like 75% of 24.
But that's a little different than 75% of 2.4.
Yeah. So then I would say, well, I feel like I would say 75% of 24 is 18. and then scaled it down to get 0.18.
To get the 0.75. So the
Mm-hmm.
0.75 times
Mm-hmm.
24 would be 0.18.
Mm-hmm.
But the problem was 0.77 times 0.24.
Yeah. I'm just in my head thinking about if would it be any different than what I had done before.
I mean, so it's a little interesting to me that when I gave you 0.75 times 2.4, you're like, I'm thinking about 75% of 2.4, and then you found the extra 2% and added it back. It sounds to me like you're have the same attack strategy. It's just that you would have been doing it with 24
Yeah.
and then scaled because you were actually supposed to do it with 0.24. That is a little different. I mean,
Yeah.
both times you were going to find 75% and 2%, but one time you stayed in the decimals.
Mm-hmm.
You found 75% of 2.4 and then 2% of 2.4. But if I had made it 0.77 times 0.24, then you're like, I'm thinking of 75% of 24, and just knowing that you're going to then have to scale divided
Um,
by 100 at the end.
you know what?
Yeah.
I was listening to you, I promise, but I was actually thinking.
You're doing
'Cause
your own math. You were like so
I am.
excited. All right, all
I'm
right,
like,
all right.
I
Fine,
actually was
fine.
like, no, I think I would think about it in whole numbers. And I was like, would I? Because I love 24 for double half. And so
Oh,
I think I would go, what I wrote on my paper just now was 77 times 24. And then below that, I wrote 154 times 12. And then I was like, would I want to go there? And then when I did the next, I did 308 times 6. And I was like, oh, yeah, because that's 1848. I know that.
you could just
And
see three.
I,
Hang on, you went so
yes,
fast. You can see 308 times 6. How do you just spell it out?
it's just
308 times 6.
300 times 6 and 8 times 6 is just 1848, kind of like left to
Okay.
right ish.
Okay.
And then because I had landed in whole numbers, I would go, okay, but I know that I have way too much of a place value shift. I got to go one at a time. I definitely do. So then I would shift 4 place values to get 0.1848.
But you're thinking you'd probably do that one at a time. You're
Yes.
like, okay, so yeah. So then Kim, with that doubling and halving strategy, you could like lift 77 and 24 out of that problem, double in half,
Yes.
get this
Yes.
1848, and then I could have given you 7.7 times 2.4. And
Mm-hmm.
with that 1848, you could then reason that you would have to shift the
Mm-hmm.
decimal
Mm-hmm.
twice. Or I could have
Well, and I
given you
might have even bumped into that along the way as I was shifting originally, right? Because when I'm considering shifting those place values, it's changing the the problem. So
what do you mean
when
bump
I
into what? What did you
you
what did
said
you
I
mean by that?
you said I you might have given me 7.7 times 0.24,
Uh-huh.
and because I was moving from 77 times 24 to 0.77 times 0.24,
Uh-huh.
as I shifted the place value one at a time, I would have considered 7.7 times 0.24,
Oh.
0.77 times. So I would have solved a lot of problems in just the shift itself.
That's
That
interesting. I'm
makes
not sure I've ever
sense.
thought about that. Yeah, it
Okay.
does. Cool.
Okay.
Super cool. All right, y'all. So that's a pretty gnarly problem. 0.77 times 2.4 that we did a
Yeah.
few ways. I wonder, you might be thinking, Pam, do we really want our students chewing on problems like this? Don't we want them to sit and just do a bunch of mindless stuff so they can get the answer and they can move on? I just took a deep breath. Because if that's what you're thinking, and I can understand why, I really can. I can empathize with what you're thinking about. Would you consider that what you just thought or what you just said was, Pam, can't we just have students do a bunch of mindless stuff and get an answer? Well, if that's really what you want with, that's the steps of the algorithm, right? We just want to do the same thing every time and just get an answer so they can move on. If that's really your goal, just hand them a calculator. They'll be more correct. They'll be more successful if your goal is to do the same thing every time without developing this thinking and reasoning and magnitude and sense of size. And like Kim just said, answering all those questions at the same time. If your goal is just to do the same thing every time and get an answer, then why waste all that time that we do to get those steps of the algorithm in the first time? And then how many times are kids going to say, Miss, is this where I line them up or where I move the decimal? And I'm going to go, nah, it's not about whether I line them up or move the decimal. It's about thinking and reasoning and using relationships because we can. And when we do, then we build our brains to think mathematically. And that is what mathematizing is all about. And we can do it. Y'all, go solve some problems thinking and reasoning. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.